Hello guys, today we're going to be discussing logarithm functions. So what we're going to do first is we're going to study relationships between side A and side B. So for example, we have side A, which is just 3 squared. What does 3 squared equal? 3 squared is 9, because 3 times 3 equals 9. That would be one side of the relationship. Now, the next side of the relationship would just be 4, or no, excuse me, no, it would be square root of 9 equal 3. This is kind of like the reverse thing. We're basically putting, instead of 3 to the power of 2, we're actually doing reverse. We're actually doing 9 to the power of 2. Well, 9 to the power of 1/2, which is just basically the same thing as square root of 9. Basically, this is what square roots mean. Basic intro you need to know before logarithms. Okay, what consists of a logarithm? So a logarithm is just y, which is just the exponent. So y is just the exponent, and then log is just a thing we use to find the actual exponent that we need to find for a specific equation. So log, and then b represents the base, and x represents the actual answer. But in this case, the answer is y, not to get confused. But yeah, but what I mean when saying that this is the answer, okay. We're gonna put this into another perspective. So we can actually rewrite it in another way. So b, which is the base, raised to the power of y, which is just the exponent, equal x, which is just the actual answer. So b raised to the y equals x. This is basically how logarithms work. So what we need to do now is just the basics. We need to write the equation in its equivalent exponential form. So I'm going to put a logarithm equation, and we're going to try to see if we can put it back into an exponential form. But before we do, I need you guys to remember this. The solution to a log equation is always an exponent. So just keep that in mind. Okay, so now we want to rewrite this equation into exponential form. So what can we see here? So remember, x is our actual answer, 5 is our base, and 2 is our exponent. Okay, so if we want to rewrite this in exponential form, we would just get 5, which is the base, so 5, and 2, which is just the exponent, and you set it equal to x, which is just the answer. And if you actually square 5, what would that give you? It will give you that x equals 25. Okay, we're going to try a little bit different problem. It's a little different, but it should be using the same logic or same way of thinking, just a different approach. We're going to try 3 equals log of b. This time we don't know b, but now we know x, which is just the answer. Okay, so we know that 3 is the exponent, b is the base, and 64 is the actual answer. Not of the logarithm form, but of the exponential form. 64 is the actual answer of the exponential form. So when we rewrite this, we know that 64 is the answer. So now we set it equal to the side. We put b, and 3 is the exponent, so we would just raise b to the power of 3. So what can we do here? So remember how if you want to go reverse, we would just multiply, or no, we would actually raise this power to 1/3, because we're raising this original power to 3, so we would just reverse it to find or to work our way back to the original number. So we would just multiply, not multiply, just raise 64 to the power of 1/3, or in other words, cube root of 64, cube root of 3, and cube root of 64 will just equal 4. So once we cube root this, we don't need to put that, and we just put 4. And we can actually double check this in our calculator. 4 to the power of 3 equals 64. Okay. I'm going to try a different example. Now, we want to find the exponent. Basically, what logarithms are mostly used for. So, we can just write log of 3 and 7 equals y. Y is our exponent. In logarithm form, remember, the solution to a log equation is the exponent. Okay, we can actually either type this thing in the calculator, or this is an easier problem, or it doesn't look that intimidating, but we still probably do need to use a calculator. So if we actually type this into our calculator, let me just type it. We go, in order to get the log base that we need, we click math. We scroll down until we see A. We put where it says log base. Then we put 3, and then we move to the right once, and we put 7, and it gives us the answer of y equals 1.77124, and it goes on and on and on. Okay, now we're gonna work things back. So now we want to work reverse, or we want to write the equation in its equivalent logarithm form now. So now 12 raised to the power of 2 equals x. So if you want to write in logarithm form, we would just write 2, because remember, the solution to a log equation is always the exponent. So you can write 2 as a solution, and we could put log because the base is 12, and we put x here because it's the answer. So, but in order to actually solve this problem, we actually don't need to use log right here. We can actually do this. We can actually square 2. We can actually square 12, or we can just multiply 12 times 12. It's the same thing. For you guys who didn't know what squaring is. So, we can just type 12, and then we would put the squaring button on our calculator, the one that says x to the power of 2, and it would just give us 144. This would actually equal x. Let's try similar problem. We can do b of 3 equals 8. So now, what can we do here? So we can analyze and see they gave us the exponent and they gave us the answer already. So given that information, we can set this equal to 3. Remember that the solution to a log is always an exponent, so we just bring the exponents here and make it the solution. Then we put log of b equals 8, because 8 is just the answer. So now, once we do that, we want to click again in math, and we scroll down where it says log base. It says to say A, log base. Then we click it, and we would actually no, we don't want to do that because we don't know the value of b yet, but we can also use that to double check our answer. So what can we do here? Similar to the other problem we just did a few minutes ago, we can actually cube root 8, or raise it to the power of 1/3. So 8 raised to the power of 3, or in other words, 8 cube root of 3. Let me just separate it like this. Would ultimately just give you 2. So in this case, 2 to the power of 3 equals 8. We can also verify this. 2 times 2 is 4, times 2 is just 8. This is a simple way of checking. Okay, now we're going to try a more different problem. We're going to get into actually evaluating them and actually solving for them. Kind of like what I was just doing. I was right now explaining how to turn them from exponential form to logarithm form, and from logarithm form back to exponential. And I want you guys to try this on your own for a little bit and see what you guys get. So I'm going to write the first question. Log of 2 of 16. So feel free to pause, or if not, just wait for me to solve it. Okay. What we can do here is we can see that 2 is the base and 16 is actually the answer in an exponential form. Not logarithm form, exponential form. So we can actually rewrite that. Since 2 is the base and we want to find the exponent, we can just put 2x, not could be confused with the answer. We set equal to 16. And 2 to what power gets you to 16. So in this case, it's really easy to find out. We can just say, oh, well, 2 raised to the power of 4 gives you 16. But in other occasions, it's a little more difficult and more complex to find. So we would actually prefer to use this one in our calculator. Oh, it just disappeared. But yeah, we would get the log base, and we would just put 2 right here, and we would put 16 right here, and the answer would just be 4, because 2 to the power of 4 will just give you 16. So our answer is 4 when finding the exponent. Okay, we're gonna do a little bit of a different problem. We're gonna do log of 7, base of 7, and the answer is going to be 149. You're like, whoa, what do you mean 1 over 49? What does that mean? Well, it most likely means, well, it has to be a negative exponent. We already know it's a negative exponent when we put 1 over a number. So what we would do in this situation is we either can punch this in our calculator and it'll just give the answer, or we can actually try to solve this by hand. So we can already see that 7 squared equals 49, but since it's negative, the 1 and 49 flipped, because 7 squared can also be written as 49 over 1, because 49 divided by 1 is just 49. So in this case, it's written the other way. It's written like this. So in that case, that means that it's a negative exponent. So that's how you deal with negative exponents. Okay, so our next problem is a little different, but it's really similar to something that we've been working on. So we can just write log of 5, actually nope, 225 of 5. Don't get confused, the answer is not 2. It is not 2, because the base is 25. Basically, in exponential form, this says this, 25 raised to an exponent gives you 5. That doesn't look right. Again, what did we just learn right now? Basically, we can just do 25, square root of 25, or 25 to the power of 1/2 to get 5. So the exponent that 25 is being raised to be able to turn into 5 would just be 1 over 2, or in another case 1/2. So 25 to the power of 1/2 will just equal 5. Okay, we're going to try a similar problem Let's see if you guys can get it. This is a little bit harder. I'm going to walk you through it, and hopefully you guys understand. Okay. Okay, this looks like an intimidating problem, but it isn't that intimidating, because we can also just rewrite this as a actually, yeah, we can just write it as a exponential form. So we know that 2 is the base, and the exponent, we don't know the exponent, and the answer gives us this. But remember, square roots also equal the power being 1 over 2. That's for square roots. But in this case, it's 5. So we just put 1 over 5. So we would just change this right here as 2 to the power of 1/5. 2's cancel out, and we're just left with x equals 1 over 5. And that's our answer for the logarithm function. Okay, now we're going to be actually doing something a little bit different. We're actually going to be explaining some rules that you need to know when you want to expand and condense log functions. So, for example, our first rule is actually the product rule, which states that log of the same base times n and m. We can actually rewrite this function as this: log of b m plus log of b of n. Basically, whenever time we multiply the answer, we can actually just add them and expand them. Now, similar to multiplication, division comes in hand. Log of b and then m divided by n will just equal log of b of m minus log of b of n. Now, for our final rule, it's called the power rule. The power rule is just basically this: if your answer is raised to an exponent, we would just write the exponent first, then the log, then the base, and then the actual answer. And that would be the power rule. This right here is the power rule. This right here is the quotient rule, and this right here is the product rule for logarithms. Okay, now we're gonna put some of these to use. So, for example, we're gonna try different thing. It's not log, but you should get the hang of it. It's ln. It's another way to write log in using different numbers. So our example is 6ln of x plus 3ln of y. So in this case, we want to condense the equation. So what we would do, we would also use the power rule. So we see that there's a 6 in front of here and there's a 3 in front of here. So we can automatically assume that these are exponents to the answers, which these are the answers. Okay, so we can just write our answers as this and our answers as this. These two will be our answers, but we're going to use them a little bit later. Okay, we can just write ln and bring it down to condense it. And we're going to put it in one single parentheses. So we bring out the x, and using the power rule, you can just put 6 as the exponent, because the exponents go here. Now, it's a multiplying because we're adding, so you might want to correlate multiplication with addition and division with subtraction when you're dealing with these logarithm rules. So now we would just bring down y, and 3 is the exponent, so we just put that. And this is how you condense logarithms. Now we're going to try a different one. We're going to do 3 log of 3 of x minus log of 3 of y. Okay, what can we see here already that we can probably use? So we see that this is going to be the exponent of the answer. So we find that log of 3 and log of 3 are common, so we can definitely condense these in a satisfying way. We can just put log of 3 and then parentheses. Okay, we bring down the x because that's the answer, and this is its exponent. We just put it right here. And since y doesn't have any exponents, we just put a division right here because minus is associated with division, and we just put y like that, or y at 1, it doesn't really matter. You can also write it like this. You can also write it like this, just x3 over y. And this would also be correct. Okay, now we're going to be expanding logarithms. So we're going to be expanding log of 5 of a power of 8 times b squared. Okay, what can we see here? Well, we see that these two logarithms right here, this and this, have a common log base of 5. So we can assume that log of a and log of b have the same base. Okay, we see there's 2 exponents right here, so we're going to put these exponents first. So we're first going to do a. So a's exponent is 8. So and we write log of 5 of a. And since we're multiplying these, we put an addition sign. And then this guy's exponent is just 2, so we just put 2 of log of 5 and of b, and you're done expanding this logarithm function or expression. Okay, now we're going to move on to expanding different logarithm. So now we're going to do ln, and we're going to do u6 divided by, we'll do a tricky one, square root of v. Okay, if you don't recall, it's okay, but square roots, they're actually written, there's the invisible 2 right here that we always write. But square root of 2 is also a power of 1/2. So we can just put x an example and x as an example. So x raised to the 1/2 is the same thing as square root of x. So using this knowledge, we can actually evaluate or expand this equation. We won't be evaluating this yet, maybe later on in the video. Okay, so now what we would do, it would just write 6, because 6 is the exponent of u. So I write ln of u, and since they're dividing, we're subtracting. And since it's a square root, we do 1/2 of v, and then actually no, not v. We put ln of v, and that's how you expand the log function. Okay, moving on, we're actually going to be solving logarithm equations. We're going to do a simple 2 exercises just to help you learn and solve exponential equations. I'm going to give you 2 examples. First is going to be a logarithm. So log of 4 and 2 plus log of 4 of x equals 3. When we're actually solving for logarithms, we actually want to find the x. So, what we want to do here is, since these two have a common logarithm base, we can just condense them. We can put log of 4 of 2, and since it's addition, we just multiply 2 times x. 2 times x is just 2x. So what can we do here? So we can just actually convert it to exponential form. We can just do base of 4. This is the base. This is the exponent. So 4 cubed equals 2x. Now, what is 4 cubed? Well, 4 cubed is just 4 times 4 times 4. And guess what? That gives us 64. So this would just be 64. We can just actually erase this and replace it as 64. And we can just divide by 2. Divide by 2 on this side, divide by 2 on this side. Once we divide by 2 on this side and on this side, 64 divided by 2 is actually just 32. And we get our answer. X equals 32. Now, for our last example, we're going to be solving in exponential form, and then we're going to reverse it into logarithm form, and this is where logarithms actually come in handy and help us find the value of x. In the other one, it was really easy. We can just solve it algebraically, but in this one, it's going to be painful. Okay, so we have 2 times 5 to the power of 2x equals 8. So we want to find x. So what can we do here? Well, first things first, we can actually multiply 2 times 5, which just gives us 10. And it's raised to the 2x. And then we equal to 8. What can we do here to get a simpler, easier number? So we would just divide by 2, which that gives us 5 and 4. Now that we have done that, we can actually just turn this into a logarithm form. In logarithm form would just be log 5 is the base, 4 is the answer, and 2x is the exponent. Well, see how here we can't really solve it algebraically, or it's going to be really, really hard to solve it. So that's where our calculator comes in handy. We just click math, and we would just scroll down when we see A and you say log base. We just put log base of 5, and then the answer would be 4. And then it would just gives us, it goes a weird decimal, and that decimal we just divided by 2, and x, it's approximately 0.43067. This would be our answer. So that concludes our video about logarithm functions. Hopefully you guys learned something new, and be tuned for next video. Bye.